Good morning and welcome to a special Solstar live cast. I'm your host, Lisa Dreer, and I'm really honored to announce our guest for today, Charlie Walker, who's the first commercial astronaut in space, and Paul Frey from Solstar Space. He is the Director of Product Development. Welcome to the show, guys.
Thank you. Glad to be
Thanks
here.
for having us.
Absolutely. Maybe we can start by having you each give a little bit of background on yourselves. So, Charlie, tell us a little bit more about being the first astronaut in space.
Well,
First commercial astronaut. Did I say commercial?
you did the second time. Yes. Well, I grew up as a child of the space age. Grew up a middle-class family in the Midwest USA, and a great school, Purdue University. Followed another astronaut from my area in southern Indiana who went to Purdue. I had my primary aim and focus in my early years as being space. I wanted to, first of all, build rockets and satellites and maybe get a chance to go there. But it was adventure and contribution to the nation and to the world in terms of exploration and the utilization of space that brought me along.
Great. That sounds so exciting. So, Paul, maybe you can give us a little background on yourself.
Yeah, so I'm the Director of Product Development for Solstar Space. I've been in the space industry about 7 years now. Got my start at Google with when they had purchased the Skybox. So I've been working with remote sensing, and that's how I got my interest in the space industry. Kind of like Charlie, I am now trying to make my career in the new space age, and it's just all fascinating getting to talk with a lot of these people.
That's great. Thank you, Paul. Charlie, maybe we can start by having you just give us a little bit more background about your experience as a commercial astronaut.
Well, to continue my introduction of myself, interested in space exploration and utilization. I got my college education degrees and started into the workforce literally as the nation was deciding that, well, going to the moon 6 times with boots in the regolith was enough, and we'll go do other things around the world maybe. And oh, if we're going to be in space, then we'll just exploit space with a reusable space shuttle, and I'll see what happens after that. So exploration was not so much in my career future, but I saw the utilization of space as being a direction that I was going to pursue most definitely. I found a corporation that was interested in developing potentially commercial industrial processes, and working with that corporation as the one of the first engineers in a commercialization project. We focused on looking at pharmaceutical processes that would benefit from the absence of gravity. Gravity controls everything here on the surface of the Earth, including the biophysical processes and fluid mechanical processes that industry works with. Leaving gravity behind to execute most of them would be a very interesting pursuit, and possibly give us new and purer metals, pharmaceuticals, materials of all kinds. That was our pursuit. And so I was deeply immersed in that, developing the processes and equipments along with our microbiologists at the McDonnell Douglas Corporation in St. Louis. We were focused on fitting in with the NASA culture to the extent that NASA was the only Western space agency with a spaceship that was going to space, and the only one that could go to space and come back again. And for a business that's producing materials out there, that had to be the way. So we focused on working with NASA as a partner to start with, and eventually intending to be a commercial user, reimbursing NASA, the Federal Treasury, for the use of the space transportation system. That was our pursuit. And I was the chief test engineer, as I said, who trained astronauts to start with, NASA career astronauts to start with, to execute our experiments in orbit on a minimalist basis. They had dozens of other things to do on every mission that we were manifested on. But the company was bold to say to NASA, these industrial researches can best be done with an expert that's most knowledgeable in them, and we have a guy who has his hand in the air. Now, truth be told, I'd applied to be a NASA career astronaut, but along with 8,000 other people were turned away. So I looked for the back door, and that was my back door, and I had the company behind me in this innovative approach to the use of space. And that got me my rides to space as a research engineer with three different test flights of our system aboard Space Shuttle.
Wow, that's just amazing. And wow, what a fascinating career. When you were in space and doing these, research studies, what were your major missions in these opportunities, and what was most important to the work that you were doing?
Well, the objectives were to first of all, to validate and verify that this process called electrophoresis was one that would work in space, would separate biological fluid, liquid biological materials, proteins, hormones, enzymes, much better than was possible with a similar piece of equipment, the best that could be designed and built here on Earth in gravity. That was our primary objective, but it meant a lot of work with equipment where literally you had to observe what was going on inside of the chamber, the device, adjust pressures, temperatures, flow rates, and electric field to get the process tuned in to where you want it to be. Now, these steps they potentially could have been automated, but it would have cost the project millions of dollars more than having a human attendant to observe, to correlate and calibrate the equipment and adjust it when something might go wrong, and even to repair it, certainly if a piece broke. So those were both the objectives and the activities that I was involved in. And of course, again, we intended to refine the process and then engage NASA in flying a complex and very large factory, a pharmaceutical purification factory to be carried to space aboard Space Shuttle, left there to orbit the Earth for a few weeks doing its thing, and then the shuttle again to rendezvous with it and bring it home. Now, that was the commercial objective, along with our pharmaceutical company partners, to get the product into space, refine it, purify it, bring it back to Earth, and then market it once we had FDA approval. So those were our objectives, and I was there again during those R&D flights as the expert of the process, the equipment that manifested the process and performed it, and doing laboratory work in space, just like I had been doing laboratory work on Earth, except in this laboratory, well, there was no gravity. So it made things considerably different. Couldn't be simulated here on Earth. Had to have somebody there. Again, given the fact that communications up and down was hard to engage at the time. So we can talk more about that, of course, as a benefit that we're looking to resolve with Solstar Space. But that was my experience.
Right. So when you were doing these experiments and studies, was it important that you had some kind of communication back to Earth, or, with other things in space?
It was very important that I communicate with my team on the Earth. I was the one there on each of the crews that I flew with, the NASA crews that I flew with, as the first commercial and industrial astronaut, not a career NASA astronaut again. But I had a team of folks who, in their professional careers and in their jobs on our commercial team at the corporation, had expertise that had contributed to the design, the development of both the biomedical process, electrophoresis, as well as the raw pharmaceutical product. From a biological standpoint, I had computer programmers and hardware people who were the experts on the pieces of electromechanical and electronic equipment. and things did go wrong during our flights. I had to replace filters. I had to replace a pump. I had to stop a leak in space. I had to reprogram some lines of software on in the computer, relatively crude computer with Z chips at the time. But I had to do that in space. I was the only one there to do it when a machine broke down, and you've only got 7 days in space on that mission. And who knows if NASA will schedule you again if you don't get it right that time. So I had needed to have contact with the experts on the ground when I had a problem to consult with them. And that was limited. So I really jammed up on awareness and knowledge that I could take with me, but you can't predict and you can't always know the unknowns when you're going to do these things. That's the whole point of research and development. So I needed to have that contact, and the NASA system at the time, as Paul can relate, was not extensive in terms of air to ground, ground to air communication.
Wow, amazing. So when you had the opportunity to communicate, I guess, how much time did you have to get those communications done?
Well, as a reminder to everyone listening, Space Shuttle orbiting the Earth on the average of 180, 200 miles above us all. An orbit lasted about 90 minutes, of course, then repeated as many times as you're in orbit for the days and weeks that you're there. But a 90-minute orbit with only ground communication to the ground over tracking stations. There were no working geosynchronous satellites that NASA was employing at the time for relay. There were no relays from geosync orbit as there are now. And so we had maybe a total out of every 20 or every 90-minute orbit, 20 minutes of communication with the ground. Now that was both spacecraft telemetry, some of the bigger payload telemetry, commands up and down, and voice, and some crude video at the time. I, being low crew member on the totem pole, followed all the NASA and the big government payloads in terms of ability and time to communicate with the ground. I might have gotten 5 minutes out of every 90 minutes to relay to the ground what I needed to get. But there was one other point. NASA insisted on the only verbal voice communication with the spacecraft be through an astronaut at what was called the capsule communicator, console, Capcom, an archaic term at the time, but we still use it today. The astronaut was the person I had to talk through. They relayed it to my backroom experts, and the backroom experts had to go through 2 other people to get to the astronaut communicator to send the response back up to me. It was
it's the world's most expensive game of telephone.
No kidding. No kidding. So Paul, things must be better today, right? What are the communications like today for on orbit in space communications, like what Charlie's talking about?
Unfortunately, they're not much better. There have been some forward momentum. I mean, NASA launched the TDRS, the Tracking and Data Relay satellites, like Charlie had mentioned, to help communicate with International Space Station and other missions like that. But even those are being retired, and NASA has said to the commercial market, hey, we are retiring this TDRS system, and we need commercial solutions, not only for us, but for the future of space experiments, travel, tourism, all the different use cases.
Incredible. That's really hard to imagine. So I think that's why Solstar Space is bringing some new solutions to market, is to kind of address that. So can you talk a little bit about what Solstar is working on?
Yeah, Solstar is working on hardware for any spacecraft for many different use cases. And what we do is we leverage existing commercial satellite infrastructure to provide a bidirectional and persistent communication with your asset in space, mostly through the internet. So that's, if you were a researcher on the ground and had a payload on board the International Space Station, for instance, you could be from any internet connected device on ground, you could be sending commands, getting data back and forth. That's more of a narrowband, sort of small bandwidth data feed back and forth. But then we're also developing hardware and services for larger bandwidth for, say, remote sensing applications to respond almost immediately to natural disasters, get imagery back, get insight to the people that need it. If Charlie had our technology on board the space shuttle for his experiments, there was a good chance that maybe he may not have even had to fly. Not that I want to take that away from him at all, because I'm sure it was incredible. But yeah, being able to interact with your payloads and your experiments from the ground, bidirectional, persistent, it's a complete game changer.
And if I might
Absolutely.
add, Lisa, to Paul's point, not every researcher either wants to go to space, the laboratory of space, I dare to say. I mean, I've encountered many researchers who have flown work with NASA or other space agencies who said, I don't want to go with this myself. I'm not that kind of personality, or I don't want to put up with the risk, and much less the time to train, et cetera, et cetera. Just fly my experiment, let me command and control it and get the data down, and then hopefully fly me again when I have learned from that and can do better the next time. But not everybody neither wants or needs to go to space. But virtually everybody that sends something there, especially when it's science, research and development, wants to have a strong connection with that.
Right. So Charlie, as kind of a astronaut and space researcher, what do you see as crucial for today's and tomorrow's astronauts and researchers that will be doing these types of experiments in space?
Well, that's the key question, isn't it? And let me summarize it to start with by saying the abstract the short answer is anybody who does research and development, my experience, and I think it is really absolutely true, research and development or science, whether it's applied science or basic science research, wants to have full contact with their experiment instrumentalities, as well as the flow of information, visual, telemetric, whatever, full contact and awareness of what's going on, and the maximum amount of opportunity to adjust real time what's happening to get the most out of the work in the most expeditious fashion. Now, whether that's done like I was doing in person with the equipment, or whether it's done through manipulation remotely. Telemetric telemedicine, of course, is a great opportunity for access to space, and but research in all industrial and, again, scientific disciplines could benefit from a broader bandwidth of communication, both up and down. That Solstar's focus on persistence and resilient command and control opportunities via the internet is, I think, a perfect example of the kind of access that researchers would want and need, that anyone who is actuating something in space, not even research necessary, but applications, assembly activities in space done robotically, but with some command and control from a distance. Again, this kind of persistence and resilience and redundancy, as well as, hey, the casual stuff. I didn't get a chance to talk to family on the ground. That was, no astronauts did at the time when I was flying. Today, they have the opportunity from the space station, but interference is always possible, and you'd like to have the most persistent and continuous and contiguous and even private access to not only data for work, but with communications with friends and family.
Sure. So, Paul, how do you see Solstar addressing some of these things that Charlie's talking about?
Yeah, so that's kind of the beauty of our solution, is that it can be applied to multiple use cases, whether that be something like Charlie was working on with science experiments in zero G, or even down to space tourism, or just being as simple as a backup option for communication when traditional methods go wrong. So really, it's can be designed to fit the mission, can be designed to fit the use case. And it's really, the best way to describe it is just an enablement technology. As we continue to grow and do more and more in space and really invest in this new space age, the communication has to advance with it to make it worth the while. So, and then we believe that this will help that solution.
That's great. So these solutions, are these only appropriate for on orbit, or do they also support suborbital missions as well?
Yeah, they would definitely support suborbital missions. I can picture a. I mean, one of the first things that we did when we were testing, so we tested on the Blue Origin New Shepard rocket twice, and both times while in space, we tweeted, from the Wi-Fi hotspot that was ongoing inside the capsule. So I can see a world where space tourism, people are using their social media while in space, with this technology.
Wow,
I hope
amazing.
they don't use it too much, though. They should be really taking in the views, but
Indeed, indeed. So, so Charlie, how do you see what Paul is talking about here, Solstar's solutions really changing or improving space-based communications?
Well, it definitely will improve things from the way I experienced them. And lots of researchers who, in the early years, I say the space shuttle era, which of course ended in 2011, and we've been a little more inhibited from commercial investigations, research, and development in space. Without such a large carrier vehicle as the space shuttle was, with a clear up and down capability. But there is a, to use that term, persistence is applied to space presence. The space station now and the prospect, not only just the prospect, but the real investment plans in commercial space stations that will not only be co-orbiting in the years ahead, but will certainly supersede the intergovernmental space station in orbit right now. Those assets will provide long-term opportunity, and there has to be resilient and secure communication both up and down with private activities, whether they're a movie studio in space or whether they're an industrial researcher looking at new industrial processes and products up there, or even the scientific community looking to stare out into the universe, but on a continuous basis, so as not to miss irregular events that we don't predict, but we want to catch them when they happen. And that kind of future and that kind of opportunity has to see communications such as Solstar is envisioning providing service. Continuous, secure, robust, and broadband opportunities, and tunable and selectable to the customer's needs and budget it's the kind of opportunities, it's the kind of capability that a user of communications here on Earth has, and it's just going to be natural to see the need for that broad spectrum of capability and opportunities to be extended, not only out into low Earth orbit, but of course beyond. We're going to go back to the moon here in the next few years. There's already private as well as government activities scheduled for the surface of the moon and in orbit around the moon. So it's not just low Earth orbit we're talking about, but beyond. And there's, I think, plenty of future opportunity there.
Wow. So Paul, it sounds like Charlie's saying that Solstar solutions could be used for some of the lunar missions. Is that accurate?
absolutely. We're attempting to, well, yes, they definitely could. Bits and bits. Like I said, we have different products for different use cases, and one of the things that we're hoping to enable is just hardware, communication hardware designed to survive that extremely harsh environment out there in cislunar space. It's unlike any sort of communications that we've seen on for instance, the internet on the International Space Station right now. It just needs to be designed in entirely different ways to survive out there, and also to survive as long as it would take for if, it's much different to fly out by the moon than it is to low Earth orbit. So um, it, it's a challenge, and we're actively working on developing the hardware that would be able to provide it out there.
That's incredibly exciting.
We've
So
all got to remember that there's no geek squad that makes it to space to repair your hardware, or even the software portions of it. So you've got to have redundant capability to modify software on board, and you've got to have resilient systems, and all of that, I'm sure, is what Solstar is both planning on and in the process of providing for near Earth orbit, as well as those crueler environments beyond the Van Allen radiation belts and the magnetic field of the Earth that protects us from cosmic rays, etc. So the robust and healthy systems that are resilient and remotely renewable, going to be an excellent opportunity for both business and for the users that do business with that service provider.
indeed. Okay, so Paul, when will the Solstar products be available?
So we're hoping to have products in orbit hopefully by 2023. We're actively designing things right now. But that being said, if you have a mission in mind and you have a potential use case for this technology, encouraged to reach out to us through the website solstarspace.com to begin designing custom solutions for your spacecraft. We are very flexible in terms of swap budgets and things like that, and our devices, we pride ourselves in them already being pretty small but also customizable. So encourage you to go to the website and reach out. Other than that, we hope to be communicating in 2023.
Wow, amazing, amazing. And from what I understand, I think Solstar Space has a WeFunder program, which is an open seed round for funding, where I think anyone can help Solstar with their mission to bring persistent space-based communications to fruition. Is that accurate?
Absolutely. I mean, if you're, and there it is, there's a link to it. It closes in a week. But if you're passionate about the space industry, like I am, it's the reason that I'm working with Solstar. It's just a great way to be involved and have a little bit of input to, the future of how we are interacting with each other and assets and space and Earth.
Excellent, excellent. Well, Charlie and Paul, I really want to thank you so much for being here today. This has just been an amazing overview of what Solstar Space is working on, and loved hearing your experience in space as well, Charlie. So thank you so much.
My pleasure for sharing, and all the best. And ad astra, go space.
Go space.
Thank you, Charlie, and thank you, Lisa.
Absolutely.